So there is a message in the chat box. It's a link for basically giving in your attendance. So whosoever has actually joined will be getting the recorded video also for the today's training. And there are few rules for the program that we have set. These are very simple rules. So first of all, I would like to welcome all of you for the training program. This is our second session for the training, and today we are going to have a real fun. So first of all, the first rule is you should always sit in a quiet, non-distracting place. It's very important because if you stay in a place which is very noisy or you are not able to concentrate, the whole purpose of the training actually goes away. Next is you should always take notes. That's pretty important because taking notes actually will help you to memorize the things. It will help you to remember whatever is there in the future that you are going to get. So it is going to help you a lot. And then next is ask questions, because until unless you don't ask questions, you will not be able to clear your queries. It's pretty important that everyone should be actually asking questions. So whatever the kind of the queries you have, whatever you feel that you have some kind of question that you feel that it may be relevant to the topic or not, just go and ask the questions. Feel free. We are here to answer everyone so that everyone understand what is being told over here, and you are able to get the best value out of all of these things. Always keep your mobile on silent. That's a very important rule. And as I am also going to do it, I request everyone to just to spend a minute and to put your mobiles on silent mode so that you don't get distracted for next 1 hour time. So I hope everyone has done it. If you can, you have done it. Please confirm the same in your chat box that you have done it so that we can proceed further on this. Now, once this mobile has been put on silent, you also make sure that in the training nobody should be indulging into the crosstalks. There are moments that you want to add on something from your side. There is a possibility that there is something that you know but the other person doesn't know, or there could be some kind of a misunderstanding on a discussion. So it's always better that you should always be focused to discuss your points with the trainer. There should not be crosstalks in between the people inside the room. That is not permitted, and that is also going to take away the time of everyone whosoever is actually in the part of the training meeting. We are going to give you some assignments. Those assignments will be sent to you, and you will have to actually do those assignments, give us the answers for that so that we can do the assessment. At the end of the training program, you will also be given certificates for getting trained on the basics of instrumentation and automation. So this is my request for everyone, that everyone should be focused on these rules of the program. And you can make a note of this. You want to take a snapshot of this particular presentation, you can do that. So this is what you should be doing it. I hope I'm clear on this. If anybody wants to ask any question on this, please let me know. Okay, so now today's training presentation will be done by Vipinji, and Vipinji is having more than 35 years of experience, primarily designing instrumentation and automation for a lot of big companies. And for last 35 years, he has been doing only and only instrumentation and automation. So you can understand the kind of the rich experience that he has, and this is the right time to learn from him, understand what is the need of instrumentation, how the instrumentation is being selected and applied to the automation technology from last 35 years, what has been the growth of that. So you will learn everything from the basics from Vipinji. So now I'm handing over the complete training presentation part to Vipinji. Vipinji, you can start now.
Thank you, Bhattiji. Welcome all, actually. Good morning to all of you.
Hello, sir.
I hope you are able to see my slide.
Yes, sir.
Okay, good. Okay. We will today our topic is temperature instruments. So today we are going to discuss about the basic principles of temperature instruments and which are used in temperature gauge or temperature transmitters. And also I will show you some actual photos installations and discuss the criteria about the thermowell. Okay. So my only request is that in case if you have any doubt, please stop me there and then itself. Okay. Don't hesitate. So today the topic is the table of contents are what are the temperature measuring principles, how they work, type of temperature sensors, thermowells. I will show you a complete temperature instrument assembly and will also touch base on the installation criteria, what we need to look into while installing a temperature instrument. Okay, so here we go. Introduction. So as you all know, temperature is one of the very important process parameter to be made in any industry. Hence, the right sensor selection and installation becomes very important to achieve the best results, both in terms of accuracy and repeatability. Okay. Now, this is a very generic statement, but obviously it's very important because temperature is one of the very important parameters in industries, particularly in pharmaceutical industries and oil and gas industries, you know, which have some very temperature sensitive processes to be controlled with good accuracy. Otherwise, the product quality will deteriorate. So, what we are going to talk about today is the basic understanding of the principles, the sensor types, installation practices, including thermowells. So, here we start. Now, there are different principles for measuring temperature. Okay. I have classified the four broad groups which cover almost entire arena of temperature sensors. So the first one is RTD, which is also known as resistive temperature devices. Okay. And the second in that category is thermistors. We will discuss in detail in the subsequent slide, but I am just based upon the main category of the measuring principles. The second broad category is expansion devices. Your thermometers, your biometallic, your bellows, your bulb and capillary. The third category is the thermocouples, and the fourth category is infrared radiations. Now, there are several factors which decide which type of the above sensors we would like to go for. And some of those factors are what is the temperature range we want to measure, what is the accuracy we are looking for, what is the response time we want to have, and what is the stability, linearity, and sensitivity we want to achieve or we want to see. Okay. So these are the broad important considerations we have to uh, consider while deciding which of the above four broad category of sensors or measuring principles we are going to use while buying any temperature sensor. Is it clear? This one, the four basic broad category. Any questions?
Yes, sir.
Okay. Now we come to one of the most important and widely used temperature sensor in the industry, and that is called as an RTD, resistance temperature device or resistance temperature detector, some people call it. Now, what is the principle? The principle here is very simple. As the temperature increases, there is a change in the resistance. Simple. So, higher the temperature, higher the resistance. So, there is a direct relation between the temperature and the resistance. If the temperature increases, temperature increases. So, this is called as a positive temperature coefficient because both go up. When the temperature comes down, resistance value also comes down. Okay. Now, in this picture, if you see, it is written RTD, RO 100 ohms, and the value. Okay. Now, generally, the most commonly used RTD is PT100. You would come across many times if you are dealing with RTD. PT100 means platinum 100. Platinum 100 means the value at 0 degree centigrade temperature is 100 ohms. Okay, that is what it means, PT100. Now, this RTD comes in various forms. It can be a 2 wire, it can be a 3 wire, it can be a 4 wire. Okay. The question now comes, what do we use? Whether we use 2 wire, or we should use 3 wire, or we should use 4 wire. Now, 2 wires generally are not used because they have some errors introduced due to the difference of resistance, cable resistance between the two leads. So generally, we don't use 2 wire. The most widely accepted configuration of RTD in the industry is 3 wire. As you can see in the picture here, there are 3 wires. Now, the advantage of this is that it nullifies the error which comes because of change in the cable resistance. Okay. So the accuracy in this case is more. The higher one is 4 wire, but 4 wire is generally not used. It is used very rarely because there is no point investing more money going for 4 wire cable when you can achieve the accuracy with 3 wire. So in nutshell, 3 wire is the most commonly used type of RTD in the industry. Okay. Now, now the second type of category of resistance temperature device is thermistor. It is totally opposite to RTD. Now, thermistor has a negative temperature coefficient. As I told you, RTD has a positive temperature coefficient. Thermistor has a negative temperature coefficient, which means when the temperature increases, the resistance decreases. It is other way around. In RTD, it was both increasing, both decreasing. In this case, it is opposite. If the temperature increases, the resistance decreases. Generally, thermistors, you don't find their application in industries. Generally, you will find most of them in house appliances. For example, microwave oven or fire alarm system or refrigerator. These are some of the typical examples which use thermistors. Okay. So this is the first category of the temperature sensors, which are based on resistance. And the change in the resistance happens because of change in temperature. Is it clear? Am I clear, or you guys have any question? Please ask. No questions?
Guys, this RTD and thermistors are something which is always confusing because these are the two major sensors that you are going to see in the field. So it's pretty important that you should know what is the difference between RTD and thermistors and where they are being used. So it's pretty clear from the presentation, but still, in case you have any further query, you can feel free to ask. Please ask questions because it's a very important thing to understand.
Okay, we'll move.
You can continue, sir. You can continue.
Now, the second broad category is the expansion devices. These are very simple devices. They simply work on the principle that when there is a temperature rise, the fluid expands. Okay, the fluid can be a liquid, the fluid can be a gas. So these simply work on the expansion principle. Okay. Now, the first example in this category is your liquid in gas glass thermometer. The most commonly used temperature thermometer at our home, which we generally use when we have fever, which has basically mercury filled in. This is also example of a temperature sensor, a very basic common temperature sensor which works on expansion principle. Okay. The second category in this comes biometallic temperature. Now here this also works on expansion principle. So it works on the expansion principle, which states that when two dissimilar metals, as you can see from the slide, metal A and metal B, so when they are exposed to temperature variation, there is a coefficient of expansion, the metal expands. See, whenever there is an increase in the temperature, all the fluids, be it solid, be it liquid, be it gas, it has a tendency of expansion. So here you can see in this picture that metal B has much higher coefficient of expansion than metal A. Since it has higher expansion than metal A, so it bends more compared to metal A, which you can see in the below picture. Okay. Now this principle is used in temperature switches. This principle is used in biometallic thermometers, temperature gauges. These are very commonly used. You will find that in the gauges, in the local thermometers, actually, industrial local gauges. This biometallic principle. So this is another type of principle which works on the expansion. The previous slide I showed you for the liquid thermometer, where mercury was there in the glass, which expanded when the temperature increases. This is an example of a solid expansion when the temperature increases. Now, this is an example of a bulb which has a fluid, and it is connected with a capillary through to the diaphragm, and diaphragm has a spring. So the working principle is, when the bulb is exposed to the temperature, as the temperature increases, the fluid inside the bulb expands, and when it expands, it exerts a pressure on the diaphragm. So when it exerts a pressure on the diaphragm gives a push, and the spring compresses. So when the spring compresses, the spindle which is inside the spring, basically you capture its movement, either linear or rotatory, and that linear movement you can then convert into a gauge movement or whatever you want to, or can be a switch connected to a switch. Okay, so this can be a gas filled also, an application of that. It can be a liquid filled also. So these three slides which I showed you, liquid, gas and solid, all three working on expansion principle, which was our second category after resistance. Any questions, please?
Application of this one, sir. Bulb and capillary sensor. Where you used this one?
Sorry? Sorry, I couldn't get you.
Application of this bulb and capillary sensor, where we are using
See,
sir.
these sensors traditionally are very old sensors actually. Okay, they were now generally, if you see, because of these movements of diaphragm, spring, and all those things, generally in today's industry, the application is same for measuring temperature. It can be any industry, so there's no demarcation as far as application is concerned. Okay. See, these principles, as I told you, it depends on, if you remember my first slide, how do we select these four? What is the temperature range we are talking about? What is the accuracy we are looking for? What is the linearity, sensitivity, repeatability we are looking for? Okay. So if your application, if this principle fits your application, you can use it to answer your question. Okay. There is, the limitation is only on these parameters, what you're looking at. Okay, not on the application. So if your application and using this principle meets all these criteria of temperature range, sensitivity, linearity, accuracy, then you can go for it. But in today's scenario, generally, people have moved away from this bulb type. Generally, it is not used. Generally, we use RTDs, thermocouples, biometallic thermometers. These are most widely used in today's industry, to answer your question.
Okay.
Now, the next and type of temperature measurement which is used extensively in oil and gas industries, okay, is thermocouple. Now, what is a thermocouple? In a very simple term, thermocouple is made of two dissimilar metals joined together. So, if I have to explain in a very simple way, if you join two dissimilar metals together, they produce a thermojunction. Okay, and that thermojunction, a voltage will be generated. So when that thermojunction is exposed to different temperature, you will see a voltage variation. Okay. So if you see the first point in principle of operation, when two dissimilar metals are connected together, a small voltage called a thermojunction voltage is generated at the junction. Okay, and this is called as a Peltier effect. So this is inherent. Okay, there's nothing, which is there's no external source of electric energy. It is generated automatically. Second, if the temperature of the junction changes, the voltage will change, as I told you. Okay. So this voltage is proportional to the temperature difference between the junction free ends. This I will show you in the subsequent picture. So the voltage which will be produced will be a difference between the difference of the temperature between the two junction free ends. And this phenomenon is called as Thomson effects. Okay.
Sir, please once again.
Okay. I will explain you in the subsequent slide. Okay. Let's first understand this slide. Maybe then it's better. See here, if you see, there are two junctions. One is hot junction. Okay. This hot junction is exposed to the temperature which you want to measure. Okay. Now this junction is of two dissimilar metals. So when you see this triangle shape, above is of different metal and below is of a different metal. These are two dissimilar metal which are joined together. Then there is a cold junction. Now this is a theoretical example which shows that the cold junction you are keeping ice bath 0°. Okay. In practical, it is a control room temperature which can be 20-25 degrees centigrade. So that time the cold junction will be 25 degrees centigrade. Okay. So for example, if this is 0° ice bath and your flame is 50°, so the temperature difference will be 50 minus 0. Okay. So then the voltage which will be produced will be based on 50° temperature. The millivolt which will be generated will be 50°, based on 50° centigrade. You got the point? Difference between the temperature difference between the hot junction and the cold junction, that will produce the millivolt. Is it clear or not clear?
Yeah, let me explain it in a very easy way. Basically, what happens, it's a physical property of the metals. So for the thermocouple, what it does is basically, in case if its two ends are kept at a different temperature, one is kept at 0° and other one is actually at a higher temperature, more than 0°. So there is a millivolt generation across the complete circuit. So what happens is, as soon as there is a difference in temperature, like you keep one junction which is called cold junction at 0°, and there is a change of temperature at the hot junction, the temperature keeps on rising or reducing. So what it happens is, there is a generation of millivolt. So pretty easy to understand that more the temperature, the more the voltage generation is there. But a catch is the cold junction temperature, because cold junction temperature in an ideal condition has to be always 0°. But practically sometimes it is not possible to keep everything under 0°, because you need either air conditioning, some chiller, or some kind of ice bath. So normally what people do is they keep the cold junction at a normal room temperature, which is somewhere around 20 degree, 25 degree. That is the normal temperature that they have. So if you see the chart on the right side, it is also showing some temperatures are also there, and then you will see the difference between that. Based on that, the millivolts are being generated. So it's pretty important that you need to know what is the cold junction temperature. Based on that, the hot junction calculation is being done over there. So normally क्या रहता है कि you just need to understand that there is going to be a voltage being generated when the two junctions of a thermocouple are having a dissimilar temperatures. And it's pretty important that the cold junction should always be kept at 0 degree for the best accuracy. I hope it has clarified things.
Sir, one thing want to clear. As in practical, where is the cold junction in the thermocouple?
Vipinji, he wants to know where is the cold junction in the thermocouple. Can you just explain on this?
See, this cold junction, see, as I told you, this cold junction basically is, in practical terms, these are the wires which go into the control room, your control card, the IO cards. Okay. The temperature, cold junction, the compensation is there basically. As I told you, in practical industry, we are not keeping in the ice box. Okay. These are going to the control room, which is air conditioned, kept at temperature of 20-25 degree. So these thermocouple wires are connected to the cards in the DCS, PLC, or whichever system is there. Okay. And there they are in there, the cold junction is configured at whatever temperature you are keeping the control room at. So for example, if you're keeping 25 degrees, so it will do an automatic compensation. Okay. So as I told you, for example, the field temperature is 50, the AC temperature is 25. So it will be 50 minus 25. So it will be actually 25. So the millivolt produced will be based on 25 degrees centigrade. Okay. This picture is only a theoretical picture just to make you understand the theoretical funda behind it. I will explain you with a table. It will be very easy for you. Say, for example, you are keeping it ice box. So the temperature is 0 degree, correct? Is it clear? Now, let's say the temperature in the field is 50 degree. Okay. If you look at the table here, 50 degree, and you see the 0 above, you see 2023. Okay. So here, if the temperature is 50 with reference to 0 degree, you will see 2023 microvolt being generated. Is it clear?
Yes, sir. Very good.
Now I will ask a question just to confirm that this is clear or not. Suppose the temperature is 66 degrees centigrade. Okay. And you have to compare with the ice box, ice bath, which is 0 degree. What will be the microvolt produced? 66 degrees.
2685 millivolt.
Okay, correct. It's actually microvolt, but your answer is correct. At least you pointed at the right direction. Good, thanks. Now, I will rephrase the question. If the temperature or the hot junction is 80 degree and the temperature of the cold junction is 10 degree, what will be the microvolt produce? Again, the question, hot junction at 80 degree, cold junction at 10 degree. So what will be the microvolt you will see?
718 microvolt.
718. No. I said 80. Hot junction is at 80 and cold junction is 10. It is not at 0. So what millivolt you will, microvolt you will see? You see the definition here.
2815. Hello.
Thank you. Thanks a lot. Because you have to make the difference first. 80 minus 10 is 70. So whatever microvolt will come will be the difference here. So 80 minus 10, 70, and 70 here is giving you 2851 microvolt. Clear to all? You see
Yes, sir.
you see a definition here. V equal to T square, where V is the voltage generated thermocouple EMF in microvolt, and T is the temperature difference in degree centigrade between hot junction and cold junction. So the example which I told you was 80 degree and 10 degree. So 80 minus 10 is 70. So from this table, 70 at 70, you will see 2851 microvolt. Okay. I hope this is clear now.
Yes, sir.
Okay, good. Now, when we talk of thermocouple, there are many types of thermocouple which are available in the market. Okay. And we have given some letter to them. Example, K type thermocouple, J type thermocouple, T type thermocouple, S type thermocouple, E type thermocouple. So K type thermocouple is basically uses chromal aluminum. See, if you remember, we are talking thermocouple is made of two dissimilar metal. So in terms of in K, it is chromal and aluminum, two dissimilar metals. In J, it is iron and constantan. In T-type thermocouple, it is copper and constantan. In S-type, it is platinum and rhodium platinum. And in E-type, it is nickel chromium constantan. Now these remain fixed. So anytime you talk of K-type thermocouple, it has to be chromal aluminum only. Okay. So these are available in the market. Again, the selection of this is based on many factors, as I told you: the temperature range, the linearity, accuracy, sensitivity. Okay. So that is there. Any question on this, please?
Yes, sir. I have a question regarding the thermocouple. I just confused on the chart which you have mentioned on the last slide. Like I said, we have a hot element which temperature is 100 degree, and we measure the control room temperature is 30 degree. And the thermocouple, as per the thermocouple, 100 degree minus 30 degree of the control room temperature. The actual temperature will be on the thermocouple will be 70 degree, 70. And then how we justify the process person, the actual hot element temperature temperature is 100 degree and thermocouple showing is the 70 degree.
Your question is absolutely, thank you for asking that question. Okay. If the process temperature is 100, okay, obviously on the screen we should see 100 degrees centigrade, correct?
Yes, sir.
Right?
Yes, yes, sir.
Now the control room is 30 degree, as you said. Okay. So 100 minus 30, you will see 285 microvolt only being generated, correct? Now,
Yes,
actual temperature is 100. So there is something called as cold junction temperature compensation. Okay. That means whatever the cold junction temperature is there, we will have to add that microvolt to this 70 degree centigrade, to this 70 degree temperature, whatever the microvolt is being produced. You got the point? So
Yes, sir.
it will add 2851 and it will add 1203.
okay. That will be the actual temperature according to the process cell temperature.
Yes, because yes, it's a very good question, very good question. Thank you. Because obviously, whatever the process temperature is there, that has to be seen. So when you do a designing, you will come across cold junction temperature compensation. Okay. So cold junction temperature compensation will take into effect the control room temperature in which you are keeping these marshalling cabinets which contains these IO cards. So it will automatically compensate for that temperature and add on to that so that the operator sees the actual process temperature on the screen. Okay. Today the temperature may be 30 degree. Tomorrow they might set to 25 degrees. So you have to then change the cold junction temperature compensation temperature so that it takes care of that variation. Is clear now?
Okay, sir. Yes, yes.
Because here example was 0 degree, so you don't have to do anything. But actually it is not 0 degree. So very good question. So that gets automatically added. So it is called as cold junction temperature compensation. And this table is given for one type of thermocouple. Okay. Each thermocouple will have its own table. So don't get confused that this is for all the type of thermocouples. No. I have taken this example from K-type thermocouple, but for each thermocouple, there is a table as per standard. There are different standards. For example, one standard is American National Standard Institute, MC 96.1. Okay. So there are different international standards. So this is I have picked from there actually for K-type thermocouple. But for different type of thermocouple, the table will be different. Okay, because the thermoelectric properties are different. Because you see the elements are different. It is chromal elumal for K-type, and here is iron constantan, copper constantan, likewise. Okay. Now, having discussed the most two important temperature measuring principles widely used in the industry, RTD and thermocouple, it becomes very important to know what are the differences between the two. And this is one of the question which comes very commonly when we are giving the interview. Okay. Generally, if you're giving any interview in a design consultancy or this thing, this is one of the very favorite questions or common question which is asked to the candidate. What is the difference? What is the difference between an RTD and a thermocouple? Okay. So I thought it is very important to put this slide. So I will just explain you briefly. RTD is more suited for lower ranges of temperature, minus 200 to 500 degrees centigrade. Okay. They have written 500 degrees centigrade, but from my practical experience, I can tell you generally we seldom use RTD if the temperature is above 400 degrees centigrade. Okay. So I would say the range is minus 200 to 400 for RTD. Whereas the thermocouple you can use for minus 180 to as high as 2320 degrees centigrade. So you can see that thermocouple we can use for really high where high process temperatures are there. For example, furnaces, incinerators. Okay, so there we have to use thermocouple because RTD will not work. The second point is RTD exhibit a very good stability and low amount of shifts. So it is seen that when you use RTD in this lower temperature range of minus 200 to 400 or 500, it exhibits the repeatability is very good and accuracy is very good, and stability means that it doesn't fluctuate. The readings don't fluctuate. Basically it gives you a very stable reading, whereas thermocouple shows poor stability and less repeatability over time. So this is one of the main difference between the two, that in terms of stability and repeatability, RTD scores better than thermocouple. In terms of accuracy also, RTD are better than thermocouple. RTDs are very resistant and can register small changes in temperature. Whereas thermocouple, they are sensitivity wise, they are not that good as compared to RTD. Okay. Response time of RTD is fast. Thermocouple has a faster response time than an RTD. So in terms of response time, a thermocouple scores over RTD. The main advantage, one of the good advantage of RTD is that it is linear. So you can see a linear graph if you plot between a temperature and the resistance. Whereas if you plot a graph, the same graph for a thermocouple, it is non-linear. Okay. RTDs in terms of cost, they are more expensive than thermocouple. Thermocouple comparatively are cheaper than RTD. So these things are very important to remember. Okay. So as I said, if your temperature applications falls between minus 200 to 400, then without a hitch you can opt for RTD. Only when the temperature goes beyond 400 or 500 as they have written here, then you don't have a choice, but then you have to go for a thermocouple. And again there is a table which shows which type of thermocouple, because each thermocouple which I shared in the previous screen has a different temperature range. Okay, is it clear? Any question on this? This is very straightforward and simple. Anything on this, please? Now see, the first, here we are talking about it, whether it is an RTD or a thermocouple, it is never inserted bare in the pipe or in the vessel. It is always put inside a mechanical element which is called a thermowell. Okay. Now, when you do that, there are three type of configuration you can go for. One is exposed junction, one is an ungrounded junction, and one is grounded junction. So, what is the difference? In an exposed junction, the thermocouple here is exposed to the process fluid. But this is rarely used because by exposing thermocouple directly, the chances of damage becomes very high. And you can use only when the pressure is less and the temperatures are not extreme, plus corrosion is not there. So these are seldom used. This configuration is rarely used in the industry. The second thing is the ungrounded. Ungrounded means it is not exposed to the process fluid. So this type of configuration you can use at for higher temperature, higher pressure, even for corrosive. The only thing is this thermocouple is not connected to the sheath like the first one, grounded one. The main difference between grounded and ungrounded is in the grounded one, since the thermocouple is actually attached to the sheath, the response time is very fast because the process fluid will first heat up the sheath and then thermocouple will see that temperature. But since it is already bonded with the sheath, so the response time is very fast in grounded junction. Whereas in ungrounded junction, you can see there is a gap between the sheath and the thermocouple. This gap is covered with a powder called as magnesium oxide, MgO, which is an insulator basically. Okay, so here the response time becomes slightly higher. Okay, so these are three typical configurations you will see. Okay, of mounting a thermocouple in a sheath. So whether it is exposed or ungrounded or grounded. Okay. If I have to show you now a photo of a terminal block, since a lot of our colleagues had gone to site and working with RTD, so I thought let me share a terminal block photo. So first you see 2-wire RTD. So these are the 2 wires, okay, of an RTD. The second configuration is talking of 3-wire RTD connection. So you can see these 3 wire connected between this terminal. And then the upper two, the red mark cross basically is your 4 to 20 milliampere, because we are talking of temperature transmitter. So the output is basically 4 to 20 milliampere. So these are loop powered, if you see here. Okay. So this I just wanted to share with you. Coming to the practical photos and installations, the terminal block, if you see here, if you can see in the last photo here, which I just talked about, thermowells, which I talked about, in which the sheath goes, can be again threaded type, flange type thermowells, welded type, or sanitary, used for sanitary applications. Okay. The photo next to it basically shows a thermowell with a union and a terminal head. Okay, a typical. And the below photo shows infrared type of temperature measurement without the use of thermowell. So this technology in industry is now being adopted very fast, because you don't have to drill a hole or puncture a hole in the pipe or a vessel to measure a temperature. You just need some clamping arrangement, and then it will measure the process fluid temperature using infrared principle. That is the fourth type of principle which we saw in the first slide. Now this is a complete assembly of a temperature element which I am showing. This is applicable for a RTD. This is also applicable for a thermocouple. It doesn't make any difference actually. So if you see here, the dash portion, basically this is a thermowell inside which the sheath is there, and this goes through a nipple union nipple arrangement, and then the wires go and get terminated on the terminal block. If you see on the extreme left side, terminal block is there. So this RTD or thermocouple wires will get terminated here, and then the 4 to 20 milliampere, okay, signal, then you can take through this cable entry out to the control room. So this is a complete assembly, temperature assembly or thermometer assembly, whatever you want to say, okay. And this is how the whole assembly is mounted, being an RTD or a thermocouple. It doesn't make a difference. It is same basically for both. Okay, so I think that's all actually. Now I leave the floor open to you to ask any questions you have on this.
Please feel free to ask the questions, because asking the question is going to take you somewhere. Without asking question, you will not be able to understand. I hope.
Sir,
Yeah.
sir, in RTD, we are using the noble element, which we call the PT100, and we know that PT100 is also a good element for the temperature measurement. Can we use another element on the three-wire RTD for the more and much higher accuracy? Like as we are using here some kind of fluid which we cannot um, just like as we cannot measure the higher accurate temperature, like that we are measuring the temperature 120.3 degree Celsius, and suddenly it is goes to 120.5 degree Celsius, but is the zero point 0.2 difference on the temperature measurement, and the process person are not uh, want to this kind of zero point 0.2 degree difference between the in the temperature. Can we use and another element on the PT100 for the much higher accuracy on the three-wire RTD?
Okay, because I lost you in between, but what I could understand from your question is that you are asking the question in relate to the RTD accuracy, correct? Am I right?
Yes, sir.
Okay. Now, see, there are
Yes, yes, sir.
there are two elements to, as I told you, some of the industries are have very temperature sensitive operations. For example, one which I worked practically in one of the plant in Ranbaxy, in which they are making medicines, and they have reactors, batch reactors, and the temperature measurement is very important accuracy, because even a small variation in the temperature will spoil the product. Okay. Now, having said that, there are two ways we can improve the accuracy. As I told you, three wire suffices in most of the applications, because it is much more accurate than two wire. But some people go for four wire because it still has better accuracy. That is number one. Number two, in RTD, there are two category of classes, class A and class B. Okay. So if you are looking for higher accuracy, then you have to specify that you want an RTD which belongs to a class A. So there you can go for 3-wire class A RTD or 4-wire class A RTD. Okay. Now these, because class A and class B are nothing but these are, what you can say, the resistance are much more accurate in terms of the resisting value, in terms of, the change in the resistance value with respect to the temperature. The accuracies are much higher. Obviously, the cost is higher compared to class B. Okay. So this is what we generally do. We generally specify when we want higher accuracy.
Okay, sir.
It's a matter of selection that if you are looking for a higher accuracy, then you go to the particular class. There is nothing much. The principle remains the same, but there is the material construction and all those things, they actually change.
Correct.
Sir, can we change the element like as PT100 to another element for the higher accuracy?
See, as I told you, PT100 is the most commonly used because it has been seen practically that in terms of the stability, linearity, accuracy, response time, it has been proven much superior than compared to other elements. Okay. RTD generally, wherever I have worked, that is my practical experience I'm telling you, I haven't worked with any other element apart from RTD, PT100 in terms of RTD. Okay. And in terms of the feedback of this, the feedback, whether it is a pharmaceutical industry or an oil and gas industry or any other industry, we haven't received any so far that in terms of accuracy, it is anywhere less than that. But having said that, in case if there is any other element you come across, okay, and you compare the characteristics of that element with respect to PT100, and you find that those are much better and and suffice your requirement in much better way compared to PT100, then you can obviously go for it. There is nothing which is stopping us not to go for. Okay. But then it is not question only of changing the PT100, because at the control room and also, you need to do some sort of, the card, it has to be compatible. The table, hookup table, has to be made based on that particular element which you are selecting. You got the point?
Yes.
Because each element has its own table. For example, PT100 at 0 degree it is showing 100 ohms. So if you are selecting any other element, the value of at 0 degree will be something else. So the table will be different. So you need to configure that hookup table in the control system. That's the only thing you have to do. But to answer your question, from my practice experience of more than 32 years experience in the industry, wherever I worked, at least for RTD, I always saw it was PT100 only.
Right, sir.
Any questions, please? It's very good questions which are coming, and I am finding it very interesting. So I would be very happy, if people ask these questions actually, so that to make this session more interactive.
Basically, what I understand from the team is you must have seen the RTDs. आप में से कितने लोग हैं जिन्होंने RTD एक्चुअली देखा है, या कितने लोग हैं जिन्होंने नहीं देखा? Can you just put in the comment box that I have seen it, like me and all that stuff? Or if there are some people who have not actually seen it, because we do have some samples with us, so we can actually provide you the pictures how it is being done, and we can provide you more details also on this. So if anybody who has actually not seen the RTD, anyway, not a problem. Now what, because it's already okay, Nagraj has used this, Lokesh has used this RTD. So what we are going to do is we are going to share some pictures of the RTDs in the future, because currently we are not having it hands on. But yes, this program at progress is also going to be the hands on, where you will be actually checking the temperatures. You are going to actually see how the voltages, millivoltages, the resistance changes with the temperature, so that you understand that practically how it works. So that will be a different part of the program, because currently we are focusing only on the online thing. But yes, we will be keep on sharing the updates on this, and this particular recording will also be shared with you. I have not seen much of a attendance from anybody here, because a lot of people have still not marked their attendance. Already more than 18 people are there in the program, but I see hardly 2 attendance going on. So I'm sharing the link again. So this is a standard form link, so that we can have a attendance from you, because this form also has got a feedback part. So in case you want to change something in the program, or in case you want something to be added to this program, like you have a particular wish list, like you want to understand what are flow meters, or you want to understand some details of the flow meter, we can curate the complete program as per your needs also, so that everyone is benefited. So we want more participation coming from the field. You see something in the field which you don't understand, like you see, say, some density meter. Now you don't understand that density meter, okay, how it works, what kind of application it can cater to, what kind of the technologies it is actually working on, or similar technologies that you want to see. So you can actually send it as a feedback to us, so that we will incorporate those things also to you. So it's an ongoing process. We want to make it more interactive, and all of you people should be actually part of a great group and great community. And my request is, please ask all of your team members, your friends who are interested to learn more, should be actually joining us, so that we will be doing it again and again. And then industry experts are always there to give in their inputs for this particular program. So it is requested that kindly, first of all, fill in your attendance as per the link, so that we understand that these people have already joined, because we will be sending you all the resources, technical resources, data sheets, how you do the selections and all that, based on the people who are actually attending it. So we don't want to jam the inbox of the people who are not attending. It is only for the attending people. So we need your attendance for sure. So I hope we have made some kind of a change in you to understand the temperature part, because a lot of you people might not be knowing a lot of things. So today you understand that, and you will be able to implement on this. We have a question and answer session already going on. In case you have any other questions, you can please ask me. Feel free to that.
Manmeet ji,
Sir.
good morning. Thank you very much for the wonderful training program. I got slightly late in joining, so can I get the copy of presentation?
Yes, that will always be there. It's a part of the process. So whosoever actually confirms his attendance, because that is the only way we can know who have attended. As soon as this recording automatically gets recorded, it will be uploaded to our YouTube channel also. You will be getting a link also. So it's always available. So whenever you want to revisit it, you can always do that. And all the plus, apart from this, we also are sending the technical resources where you know what are the IEC standards, what are the international standards for measurement and all that. That also we will be sharing. So I request you to all to get registered in this form, so that we understand that how many people have attended this particular training, and we'll be sending you all the data.
Yeah, I'm greatly thankful to you for this wonderful training program, sir. I hope you will continue with the more such training program on density meters, flow meters, and all.
Yes, sir. Yeah, that is the whole idea. That this program is on every Saturday. It's going to be there. It's an ongoing process that is going to. We are asking for inputs from the field, like you people who are actually using some instruments, or you are interested to use some instruments, so that you give us a feed, like you want a density meter understanding. So we will have a one session purely for density, so that people understand that there is an instrument called density, what are the methods, how it is being used, and all that. So we need that proactive approach from your side also, and we will create that content, the training program for you, sir.
Thank you. Thank you.
Okay. Any more questions? Anybody else who wants to? लोकेश जी, आप कुछ कह रहे हैं? Okay. So
yes,
what
sir. Like as जैसे सर ने भी
Yes, लोकेश जी, आप बोलिए.
सर जैसे सर ने भी कंफर्म किया था इन द थर्मोकपल like as the grounded, ungrounded, and the open in the thermocouple. At like as ऐसा RTD में भी सर कुछ होता है, जैसे कि RTD का जो एलिमेंट होता है वो ग्राउंडेड, अनग्राउंडेड और ओपन हो मेजरमेंट के लिए. Second, temperature measurement.
In RTD also you can do the same thing, but I see there are two aspects. One is the theoretical aspect, which tells ki these three configurations are there. Practically, the majority which is used is the middle one. Okay, and the reason for that is I tell you, the choice obviously should go for the first one because the response time becomes higher. Why generally we go for the middle one is because if you see that the earthing of all the field instruments and everything basically is done only on one side on the control room side. Okay, so if you take a grounded junction here, then you need to put an isolator in between in the control room. Okay, because you can't have two earthing. You can't have earthing in the field side and in the control room side because it will induce a EMF effect, because of the earth resistance, there will be some sort of noise which will be going around. So generally in the industry, practical application is to go for the ungrounded junction inside the sheath. Then you have two advantage. Advantage is that it is not exposed to the process fluid directly, so the life of artery thermocouple increases. And the second thing is you can do conventional earthing on the control room side. So you don't have two earthing, you have only one earthing. So you remove any chances of earth fault or any earth fault current flowing through the circuit actually. Have I answered your question?
Yes, sir. Yes, sir.
Okay.
Earthing is also the grounding of the instrumentation is also a very big subject that we'll be covering little later because
Yeah.
as Vipinji said is basically connecting to different earths is also not recommended. So either you should be having a earth particularly isolator for particular instruments, or you do the isolation only in the panel itself. So you don't do it in the field, you do it in the panel so that the loop EMF doesn't get generated. And that's a very practical thing and a very practical problem with the instrumentation wiring, that the engineers actually sometimes do the earthing in the field also and then do the same earthing in the control room also. And there is a potential difference between both the earths, and then you see the loop current going on and the EMF getting generated and the signal gets distorted. So we will be covering it little later because that is a little advanced subject as compared to the basic instrumentation. But in case there are any more questions, you can ask the questions for related to temperature today. Okay, now we have already passed our time, and I think we were planned to close it by around 9:15. So we are already 5 minutes past. So I would like to thank you everyone that you have spent time over here. And what we are going to do is we are going to send you all the details for this. So thank you very much. Keep up learning and keep up sharing your learning with all of your friends so that everyone is benefited. Thank you very much. All the best for the day. Bye-bye.
Thank you all. Thank you very much.
Thank you, sir. Thank you very much.